Hello everybody, and welcome to your next programming lesson. Today we're going to be talking about how we define variables and functions in C, how we pass values into functions, and how we can actually change them inside the functions using pointers, which is a very, very important subject. So pay attention and let's learn something new, right? Before we start, we will have to learn what a C program actually runs at the start. What you're looking at is the main function. This function is executed at the start of every C or C++ program. It is the core entry point, the main entry point, right? That's why it's called main, obviously. And it can either take no arguments or two arguments. The number of parameters, which means if I compile it right now and I run it as basic and I add, for example, XYZ, that's one parameter, it would actually take an array of two strings. One string will be basic because that's what we ran, and the other string is XYZ. So the program itself is actually also an argument. And argument count is the total number of arguments listed. The main function always returns an integer value. When it's successful, it returns 0 or exit success. This is defined in std library. And and we use it just because it's more verbose, right? Some people might not understand if we just type return 0, because 0 is a false value in Boolean algebra. So it's a bit confusing. But this is because of how bash works. Because bash actually takes any non-zero value which is returned as a failure. So we could even do return exit failure, which in this case is 1, but it can actually be like 5, and it would still count it as a failure. If we actually compile it right now and run basic, A it out, we can see that my terminal marked it as an error. All right, so now that we know why the main function returns an integer, we actually have to learn why the main function even exists, right? If I'm just going to do an alias here really quickly to say run equals this command right here. And I do run. And it doesn't do anything right now. But I compiled it, and if I look at the object dump of the executable, we can see that there is a start function, disassembly of section text, which is what actually is compiled from the file .c. And we can see that there's a start function. We didn't define it, but our compiler defined it, which calls main. Well, main is all the way down here because that's the first function we defined. And we can just see that it returns a value. It does some stuff in the stack. I don't really know what it does, but it returns a value which we already know, right? Okay, if I create another function, I'm just gonna do int fn, right, return 0, and I'm going to return fn, which is valid because fn returns 0, so we will actually return exit success. So my bad. I compile it and I do object dump of the basic executable. We can see that what main does is that it calls function and it returns the value of literally the function, right? So that's how basically the executable is disassembled, where the main is all the way at the bottom and then just calls stuff from the top. All right, now let's get to variables and functions. Okay, so let's say we are game developers, right? And we want to program a game server where we have to count how many players there are. So I'm going to create a variable called player count, which currently does not have a type because C is a strongly typed language, which means that we have to set a type. Now, the majority of types in C are numeric, which means that I can say it's going to be an integer, it's going to be a floating point number, it's going to be a double, which means it's a double precision floating point number. But in my case, I want it to be an unsigned integer. Well, why unsigned? Well, the player count is never going to be negative, right? We don't want a negative amount of players. Now, the common misconception is that unsigned int specifies only positive numbers. While that may be true in practice, what unsigned actually means that it has no sign. It doesn't even track the signed bit. Now, we would call that a magnitude, right? An absolute magnitude of a value. So when we use unsigned, we do think of positive values, but in reality, it's just a magnitude of some kind. I'm going to shorten it, right? I have a header file included of std which means standard integer types. And I'm going to use the unsigned integer of 32-bit types. Let's look at how it's defined. It's actually defined as this middle type. I don't know why that is, but we can see that it's actually unsigned int. So it doesn't really matter what I use, but I just like this way more. We can actually even type def it to uint 32-bit to uint, right? Or U32. Some people, mainly people who come from like Rust-based languages, they use U32. But I like unsigned in 32 type because it's very verbose, but still very short. And I have autocomplete, so I don't really care about the underscore, right? All right. Well, let's say that we have some logic here that creates player in the DB database, and then we have to increment the player count up 1. There are many ways how we can do that. We can just set player count to itself +1, right? Or we can use this shortened version, which basically does the same. It says, well, we have player count, right? Assign a value of player count plus this value. So we can even do plus equals 5, and it's gonna be equal to this. That's fine. Or if we only want to increment by 1, this is a special syntax mostly for loops, we use player count ++. Or actually, we can even use ++ player count. I will not get into the difference now. We will talk about that when we do more complex loop-based programming. Okay, I like this one the best because it's very it's verbose, but still shorter than just using player count equals player count +1. All right. Well, we will create more players, right? We created more players. We created 3 players, and we can print the amount. We do long unsigned, and a new line, and player count. Now, if I run this, oh my bad, I have I have this this function here which shouldn't exist. I mean, it doesn't exist, but it shouldn't be there. I run this, and it outputs 3. Yeah, it outputs 3, which is valid. We have 3 players created. I don't want to do this in the main function. That's very bad practice. If we did every single piece of our code in the main function would be billions of lines long, right? We don't want that. I want to create a function that is going to be called add player, right? Now, this function right now doesn't have a return type, which is something that we need to do in C. We can either say that it's going to return unsigned int of 32 bits, right? And it's gonna take an argument of also unsigned 32 bits, and it's gonna be the count. And we will see that it's gonna return count plus 1. Well, that's completely fine, but we will have to assign to the player count. Oh, sorry, like add player, right? And we will have to pass the player count, and we will have to do this every time we create a player. if we run this, it's going to tell us that it's free again. Because, well, if we look at the function, what it does is literally what we said that we don't want to do, right? It does, my bad, it literally does player count plus 1, and it assigns it to here. So, in my opinion, that's not the ideal way to actually modify data from one function to other function. I'm gonna say that this function will not return anything. Well, why is that? Well, because I don't want a return type. I do not want the function to return anything. I only want to modify the count inside and say that it will equal to itself plus 1. All right, let's add players, right? Straightforward. Edit 3 players. I'm just gonna put the player count inside so that we can pass it and it can increment itself. Well, I'm gonna run, and it's 0. Now we are getting into a very problematic piece of programming in C that many people do not like. There is no such thing as passing as reference in C. This is a copy of player count. This is not the same variable. This is a copy. It's gonna be only in the local scope of this function. If we want to pass it as a reference, we have to use what's called an address pointer. Now, let's get into pointers. An address pointer is signed in C with a star. This basically means that count is not a uint32 type, but it's actually an address in memory to a uint32 type. What I mean by that is, this is a 64-bit or an 8-byte address somewhere in my RAM, right? We have RAM. We have so many little spots where to put some memory. This is occupied memory, this is free memory, and somewhere here lives our count variable, and it has its own address. It has some kind of address. So this is what it is. If I want to use it, the actual value in the function, I have to do something that's called a dereference. So I take this pointer reference and I dereference it, and what this is now, in the parentheses, is actually uint32 type, right? It's not a pointer anymore, it's actually a number that we can increment, and we can actually see that once we would compile this, well, not yet actually, because if we want to put something as a pointer from the main function or from another function, we can see that right now it's just a 32-bit number. But if you want to do a pointer from it, we have to reference it. So this is how we designate a reference or a pointer into the function. We then dereference it in the function, we add 1 to it, and we're basically telling the RAM, add 1 to a variable at this address. Simple as that. Now when I compile it, it's free, because we send the address to the variable, it added 1 to it here, and then it just stopped the function, right? We don't need to return anything from the function because it literally did player count like this. But we really do not want to use variables on their own. We usually, because we know that there will be some more logic to it, right? For example, I want to have a multiplayer game where 4 people can join a lobby at the same time. I'm gonna say if the value is greater or equal, it's never gonna be greater because I'm gonna be making sure of it. 4, it's a 4-player game. I'm gonna just return from this function and I'm not gonna increment. And as you can see, I will add 6 players, but when I run, there's only 4. So that's the whole point of functions, right? We are doing a simple task, well, a seemingly simple task, but we can add more logic. And we can even add the database connection logic here and stuff, right? where we would do like a db address here or something, right? But this is why we use functions. Now, this is a very small part of how we use pointers. Let me do an example where we do not want to use pointers, okay? So I'll create another void function, and I'm gonna say write player count, or actually maybe log is a better word. So I'm gonna be logging the player count into the console. Obviously, I have to pass the player count into it. It's a 32-bit. And I'm going to do basically this right here. I'm just gonna use printf because I'm lazy, right? I'm very, very lazy, and I do not want to write this terrible formatting printf function. I'm just gonna write log player count. I'm gonna put the number in, or in this case, the pointer in, and and it's gonna write this for me. Now this will work but why don't we want to do this in this case right now? Well, it's because, as we said, on a 64-bit system, a pointer to any data in memory in RAM is 64 bits, which is 8 bytes. But guys, the value itself is only 32 bytes, and I'm not modifying it in the function. So it is actually more efficient for me to just copy it because I'm not modifying it, and I'm only going to be copying 32 bits instead of 64 bits. And when I run it, it's going to do the exact same thing. This is actually very crucial to keep in mind because in a big program, you are going to be doing these instructions thousands of times per second, all right? And that could equal to actually megabytes of wasted memory data. So keep that in mind. Well, guys, thank you for watching this video. I hope that you understand at least the logic behind why someone would create pointers, why we use functions, what return types are in functions, when it's better to use an integer or a void function, and how we pass in data to the functions effectively. All right, thank you for watching. I'm gonna be looking forward to teaching you in the next video, which is probably going to be on structures.